Example 3. A pharmaceutical manufacturer produces a heart medication in 50 milligram tablets. The quality control manager conducts a study to determine if this is true. She selects a random sample of 20 tablets that average 49.7 milligrams with a standard deviation of 0.6 milligrams. Is the difference statistically significant at alpha equals 0.05? Okay, so first let's find out what the claim is. The claim is that the heart medication is 50 milligram tablets. And so the null, that would be equal to 50. Now here's what's weird is I believe, let me check the textbook again. I think they actually say less than, but I don't agree with that on this particular problem. No, I'm wrong. The textbook does say equal to. Yeah. The claim is that the mean will equal 50. Which means the alternative hypothesis is that the mean does not equal 50. So because it's a not equal to 50, there's going to be two tails. You could fail being too small or too large. All right. And they tell us that the mean of the samples is 49.7 with the standard deviation of 0.6. Now, is this difference, and I'm just writing down these values so we can keep track of it. The mean of the population will be 50 here, and this happens to be the claim. And so that's the claim, is that it produces them in 50 milligram tablets. 50 milligram, there we go. So anyways, we're back over here. We sample 20 tablets. So that's the number of 20 samples, and we get that information. And we want to know with alpha being 0.05. Okay, so I come back to my calculator. I refreshed it so you can see this all again. I have an alpha already. It's the standard 0.05, which is 95% confidence typically. The tails, I'm going to say 2 because we could fail if it's too small or too large. That's why it's 2 tails, which, by the way, this kind of explains it in hypothesis testing. My calculator froze here. Let's see if it'll wake up here soon. There you go. If you scroll down here, you can see if the mean is the alternative hypothesis is that the mean does not equal some value, you would call it two-tailed. So that's what I have here. And I will type in my values. We're saying the mean of the population is 50. The number of samples happens to be 20. The mean of those samples is 49.7. The standard deviation of the samples is 0.6. The test statistic is negative 2.236. Now you're going to see this falls in the critical region because that's the z value that's created at 95% with 2 tails, which means that's the z number for 0.025, and this would be for 97 or 0.975 is where those numbers come from. If you did the quantile function, that's where those would come from. For that reason, the t statistic here, we would say it fails again, or I say fails. It falls in the critical region, which means we're going to be going with the alternative hypothesis. So here, the t statistic, the test statistic, I should say, is negative 2.236, which falls in the critical region. So this is, since it's less than 20 samples, this is the t value. It's the t-score for alpha divided by 2. And this is the other t-score for 1 minus alpha divided by 2 is how you get that one. And so the reason, the numbers you heard me quote earlier, what's happening is if I went over to the student or t distribution, what we're seeing here is that a value will be calculated. I don't want to go all into this, but it's that negative 2.093, you see it there, and 2.093 right here. That's where those values are. It's going off of this alpha divided by 2. And so that's the math that's occurring in your calculator. You can see this area shaded. Now, if you're wanting to know where's the whole distribution, like this has a whole distribution, you need to go to the alpha visualizations and turn that on. So on this particular case, I would turn on both the left tail and the right tail. I can zoom in. And you might look and say, well, that's not exactly equal. And that's because I made a mistake. I turned on the normal distribution. Let me fix this. I need to turn on the t distribution. So I'm going to go down because I'm less than 20 here on the samples. And so I'm going to go this value, and I need to have degrees of freedom. It's always one less than the samples. So 20 minus 1 would be 19. And so you can now see that this is in fact in that shaded region. So it's in that critical region, that test statistic. This should light up blue if it's ever in the critical region. That's the way I programmed it, just to draw your attention to it. So this would, what we would say is we would fail our claim. The evidence, we would reject, I should say, reject the null hypothesis or reject the claim, or null hypothesis. Which again, you could rewrite as H0. We would reject the claim or the null hypothesis in this particular problem. And I should include here based off of the evidence, based off. So we might think that looks pretty good, having a 49.7 milligram. They might say, well, that's pretty close, but with that standard deviation, it's we can't state that with confidence, 95% confidence that we will be giving people 50 milligrams. That means we fail to accept, we don't fail to accept. We would reject the claim based off the evidence that the null hypothesis is true, that the mean is equal to 50. So with that piece of information, I'm now going to let you try another. Pause the video. If you need more time,